Hey friends, welcome to our YouTube channel, Verification and Testing Guide. So, this is the introductory video of digital electronics, and in this video, we can learn some of the basics of digital electronics, and upcoming videos, we can learn digital electronics as well as the HDL language, where Verilog and System Verilog and UVM, everything will be covered. So let's jump into our topic. Introduction of digital electronics. So when we think or speak about digital electronics, in our mind, what and why is the question rises always. So let's clear the answer in this video. So what is digital electronics? The digital electronics is a field of electronics involving the study of digital signals. Then what is the question rises in our mind? What is digital signal? Digital signal is nothing but binary. Let's take now binary like 0, 1, 0, 1, 1. So digital electronics is a field of electronics involving the study of signals and the engineering devices also that produces or uses them. This is actually a contrast to the analog electronics or analog signals. So what is analog signal? Then we will be coming to this question. So then strikes a question like analog signal and analog electronics is different. That's we know. What is the particular difference in that? So analog electronics are the electronic system with the continuous variable signal. In contrast, where the digital electronics were usually to take two levels of system, right? 0 and 1. These are the levels of system in digital electronics. But in analog electronics, the levels of system is continuous range of variable signal. So it pinpoints many things. So in the next, what we are going to see, like, okay, we had a generalized answer for digital signal and analog signal, what it means now and why it is used. Okay, what about the signal? So what is signal actually? Let's take an answer. Okay, what is signal? The electric current or magnetic field used to convey data from one place to another. Okay, we can take an example for that. Like in old period, we will be using a telegram, like our telegraph. Yeah, it consists of wire. One signal reaches and another signal is output, and this is the input. So it is used to convey a message. So the simplest form of a signal is DC current. In this graph, we will be taking a DC current, right? That is switched on and off. This is the principle by which the early telegraph worked, which was in use to transfer messages by wire long ago. Now mail, WhatsApp, everything came. It's always digital, right? So why it is always digital? That is the another question. So we have to answer for that also. Now we got a generalized answer for signal. So there are two types of signal, digital and analog, right? So digital and analog we have to see. Let's see. Okay, fine. What is analog signal? There are two basic ways of representing a numeric values. So physical quantities with which constantly deal in our day-to-day life itself. I will show the example in our day-to-day life how analog and digital signals plays a major role. So first we can see analog signal. One of the ways referred to an analog signal is to express a numerical value of the quantity as a continuous range of values between the two extreme unlimited values, like right, like 1 to 0 to 1 itself, it's an unlimited value. So continuous range of values becomes an unlimited extreme. Hence, for example, generalized, I am saying today I am on Tamil Nadu. So in there 0 to 100 degrees Celsius, I am in between 31.70 degrees Celsius. Yeah. In north side, there is a Celsius like 27.25. We can tell 27 or we can represent or 27.96. Then it will come 28 degrees Celsius. So there has been a cutoff But in analog signal, there won't be a cutoff, like generalized value, continuous range of value will be noted down. In voltages also, like if we are having a 7, for 90 nanometer process, we are going for that means we will be using 1.8 voltage. We will be generalizing round off the voltage because we will be using the digital signal. The analog signal will comes like 1.89 V, like this. So these are the simplest example what I can give from my side. So digital, what is digital signal? The other possible way, it's a just represent the digital signal, the numerical value of the quantity same as the analog signal, but in step of discrete values, like in a binary numbers. For example, if you are going for in Chennai, I told like temperature is 64 degrees Celsius or 32 degrees Celsius or 32 point something floating points are coming means we will be rounding off until 31 degrees Celsius today. Like that, it is a generalized step. Okay, now we got what is analog signal and what is digital signal. Now let's summarize both of them. Let's see. Wait. Okay. Whatever we learn now, analog is a continuous output. The values will be a continuous signal. While the analog representation gives a continuous output, a digital representation produces a discrete output. Second thing, the analog system always contains a device that process or work on a various physical quantities represented in the analog form. And digital system is nothing but a device that process or work on a physical quantities in a digital form like zeros and ones. In there, the values will be fluctuating while in the continuous range. So nowadays, why digital is always used? We have to check on that also. Wait. Okay. Now, why digital is used nowadays? This is our question. So digital techniques and system have always and prior advantages among the analog signals, being relatively much easier to design, right? It's because zeros and one and having higher accuracy as well as the programmability. Higher accuracy will be there, the programmability will be there, immune to the noise because analog is continuous range. So in which particular range that the noise has been inserted, we don't know. So it has been clear cut. It is very immune to noise. Now to store a data for analog signal is very difficult, but to store a data in a digital signal is very easy. And the fabrication of an IC, it's a very big step, but I'm still in a basic level for digital electronics. So just in a circuit, integrated circuit form, the fabrication will be very easy for digital and leading to availability of more complex functions in smaller size. So I will tell you a super fun fact in this video. You will be enjoying that. Like the fun fact about the analog is in real world, however, the analog we are making as a very difficult and complex thing, but most of the physical quantities like position, like I'm standing here or something, it's acceleration or velocity of moving speed and forces and temperature, moreover, etc. and etc. Whichever, whatever you think in real world as a nature gifts is analog signal. So it's like a mic, you know, right? Everyone knows a mic is there. So the input is analog. It will be converted and formatted and processed in digital and get output as an analog. So the mic is received and amplifies also an analog signal. So the fun fact is in real world whatever the God gave us is in analog form. For our compatibility, we are converting that into a digital and processing the data into a digital because these many things are in advantage for us. So okay, fine. Now let's jump. Then why we are using digital signals? That's how we are making the video. Okay. to reduce the complexity. Just we know, right, to reduce the complexity. But how and why? Let's see. A data is there, a signal is there, we are processing and converting, and the process has been done in the from the nature. The analog signal is coming, we are processing the data. Now we need an output which we needed. That is why the analog variables or something signals represent these quantities need to be digitalized and discreted. So digitalized or discreted are same, 0 or 1. You can making to program ability. You are making the analog signals to make whatever you need, that input if you want to benefit from features and facilities that come from with use of these digital signals or techniques. In the typical system dealing with the analog inputs and outputs, analog variables are digitalized at the input level with the help of analog to DAC, right, digital to analog converter, or analog to digital converter. So here we will be raising a question: what is DAC, right? What is DAC, digital to analog converter, or DADC, wire analog to digital converter? Okay, you are right. But in the analog to digital or digital to converter is there, but we can discuss in a later part of the series, because it is very early to discuss here itself, because we have to see the number system, many introduction, many things are there. What is flip-flop and what is combinational circuit, what is sequential circuit, in combinational circuit what and all is there, what is K-map, these things and all you have to know. Then only we can jump into a bigger part of a period, because DAC plays a major role, because you have to convert an analog signal to digital is little bit hectic, right? So but it is a very easy, it's a very easy thing. Now we can just jump into this. Like in a typical system, always the analog inputs and outputs, analog variables are digitalized. Okay, if it is a only analog chip, okay, the inputs are analog and outputs also are analog, but also we will be having a digitalized format here to process the data with ease. These are the basic things you have to know when you are starting to study, or you are a professional who are working in kind of like whatever thing, like you are a RTL engineer, or else a DFT, or else a DV engineer, whoever But digital electronics basic things you have to be very clear. What is signal and what are you dealing? You can be dealing around everything on testing or else in verification part, but what you are doing you have to know. So from the scratch we are just going on. So next video will be coming on the various number systems commonly used for digital representation of data. Still now I can point out, like many of the engineers won't know the hexadecimal conversion, because many of the programming languages like SDL file or STC or SPF file will be consisting of hexadecimal numbers. They will be just go to the Chrome and conversion will be taken place there, or to nanoseconds to megahertz also many of the engineers will be doing in the office. So just like I'm saying, full-fledged you start from the scratch, just like that, from point one first day this is. So at the last day you will be master in digital electronics. I can make it out. Yeah, thank you guys, thank you for watching.